Hi, Dr. Schmidt. Good
Hi,
evening.
Anita. Good evening.
I just happened to say hello because
Oh.
I still did not finish my homework. But do you, I can show you how much I have today. It's crazy. I've never had this much homework before. Look,
That's what you have to do for tomorrow, writing
yeah. I have a big essay due tomorrow. I haven't started on that yet.
Frankenstein.
Have 2 chapters due. Frankenstein is such a good
But
book.
you have a chapter, you have a big essay due and reading to do?
Yeah, and then math I have homework, chemistry I have a project, have a worksheet, and French I had a test. I'm not gonna review for that. And then I don't even know what's going on here. And then history, I don't even know what's going on. It's like basically writing notes for review sheet and stuff like that.
Wow.
I don't know.
I think people are doing a lot of homework for this online stuff.
Yeah, exactly. But Dr. Schmidt, good news. I made some physics review sheet.
Okay,
Yeah, do you want me to send one to you so you can send it to everyone?
sure.
Yeah, I'll email to you right now. It's really
Okay.
simple, but like I actually put efforts into making it. But
I will put it into the class OneNote.
yeah, that'd be good. But there's some like small Chinese on it. But like that's not a big mistake.
Well, it's probably just a clue to who made it.
Yeah. Or Andy.
Or Andy.
I just sent it to you.
Okay.
Can you see it?
Yeah.
Awesome.
Oh,
Oh, there are a
nice.
lot of Chinese.
Yeah, there's actually quite a bit of Chinese.
Oh my god. Can you delete the Chinese or do you want me to do it? Because I can do it too.
Well, I can delete it if you want me to.
Yeah,
Here, let me save it. Oh, there's Luke. Oh, Luke is in class. I wonder why he's coming.
that's so true. Why is he here?
I don't know. He's never come to evening class before.
Hello. I just I just had a extra question. I'll just
Okay.
I'll just I'll just ask the question and then leave.
No, it's fine.
Sorry. I mean I can stay, but like
Well,
I
so
don't know.
far, nobody new has come. Anita just wanted to, she made a review sheet she wanted to share with the class. So
Email it. I'll take it. I'll take everything I can get.
I'm going to put it into the OneNote here in a minute, as soon as I get done editing it.
Yay.
Yay.
Um, Mr. Dr. Schmidt, the question I
Yeah.
had was about circuits review number 2.
Okay.
Um, I'll share my screen right now.
Okay.
Uh, um, so basically, um, so I like kind of almost redid it. I like rewrote everything. But like I came to this problem, I guess, where it was is the change in voltage um
Your handwriting is
in
so
bulb.
cute. Sorry. Keep going.
Thank you. Um I'm not sure how to feel about that. um the change in voltage in bulb 1, is it the same before the switch is closed as after the switch is closed? It isn't, right? So well, I was kind of stuck after like I realized that it really shouldn't. Um,
Okay. So before a switch goes, power is equal to IV. Um, I would, so then V is I over R, right? So power is equal to I squared over R.
Wait. Oh. Wait. Oh, so I equals voltage over R. Wait. Oh, wait. No. So you did equals IR. Oh, okay. So this is what you did?
So I just, yeah, I'm just suggesting that you replace. So you're saying P equals IV, and I'm saying replace P equals IV with. It's not drawing very well at the moment.
So P equals, wait, so P equals IV would be P equals, wait, sorry, okay.
So P equals I squared over R.
I squared over R.
And now you need to find I.
Oh, so then I can just do, wait, change voltage one, it's not equal.
So I is E over 2R, right? You have that here.
Oh, yeah. So then,
okay. So then P is equal to, yeah.
E over 2R. Okay. Okay. Thank you.
But is that right? P equals IV? I mean, wait, so P equals IV, V equals IR, so P equals I squared times R. Sorry. I think I said that wrong.
Okay. Oh, crap. Okay. Crap. Okay. Here. RT. Okay. So then times 2R. Okay. So then
no, it's not RT. It's just R. It's just R.
Oh, just R.
Because you're looking for the power through bulb one.
Okay. 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 That's not okay there. Okay. So then this is that. And then that means P new.
So P new is the same equation, but it has a different I.
Okay. Squared times wait, R. Yeah, no. R.
Still times
Same.
R, yeah.
I'll just, you know what, that's fine. Let's just do that. Okay, so then over 4R squared, 4R.
Okay.
And this equals 4/9 E squared over R. Oh, so then I just have to do P new.
P new divided by
P1 equals or then I was just gonna do this over 9R all the way over E squared over 4R. So then I can cross that out, cross the E's out. So then I get 4, yep, 4 over 36.
Oh.
Or wait, crap. Okay, there we go. 16 over 9.
Yeah.
So then, okay, so then P new equals 16 No, it's P1. Okay.
Okay.
Okay. Thank you.
So then that's more.
Yeah.
Okay, great.
Okay. Thank you. Thanks, Dr. Schmidt.
I guess we're not going to get, I mean, it's already 9:07. I don't know. Usually we get Anfisa. But
I think she has some family things to do,
okay.
but I am not sure. Yeah, that's what she told me a week ago.
Oh, well.
Also, I
Yeah.
had one more question.
Yeah.
For this, would I get the points here? Like, I mean, I kind of looked at this and I thought, how accurate could this be? Like,
For the arrows that you're drawing?
yeah, for the arrows.
Well, so they've given one for you, right? The south one they gave for you. So the north one is
Yeah.
going to be, the north one's going to be like that.
Oh.
Okay.
Wait.
Yeah. Like
All right.
straight out.
I mean,
just like the south one is straight into it.
so then these would just be all right. The top three would just be all facing the right, like parallel to the thing.
Not parallel. I think you're correct. I'm just double checking.
Because I always thought like,
Yep. So
like, I know it's like this, but like, I don't know. I
yeah,
thought
you're correct. But so the north one isn't curve, right? The arrow doesn't curve.
Oh yeah, no.
At this point, it's like this.
Oh yeah. Okay. 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 Thanks, Dr.
No problem. Thanks for giving me something to do this evening. Well, I probably should grade.
Dr. Schmidt,
Yeah.
are we really not gonna have class after this?
No, we'll have class, but I just won't require people to come, so most people won't come.
I'll probably come.
I would need.
But if you want to do something after, just let me know and I'll try to do it.
Dr. Schmidt,
Also, I usually have a party the night before, but I don't know how to do that.
What do you mean?
So when I taught, last time I taught an AP course, it was actually a few years ago, I always had a pizza party the night before the exam.
Why?
Why?
Yeah, because
For fun?
for fun.
I think by that point, if you haven't really studied, I think it's not a great move to like cram a whole bunch the night before.
Yeah, I don't think so either.
So just to try to encourage people to not stress too much.
Yeah, I mean, like it's an AP class, and like you should review many times before the day, exam day.
And I mean, you probably know it already. You're not gonna cram it in your head in the last second.
Yeah, I feel complicated about not having a class or like less people attending a class after the exam is done. I don't know. I just feel sad. Like this class has been here for a year. Remember how we were like counting down from 98 class times?
Yeah. That number was completely off.
Yeah, and then everything just flashed over and like, I don't know. Like, I could never imagine myself right here, like today, 98 classes ago. Or like, do you get how crazy it is? I don't know. It might just be me because maybe like seniors are more used to this kind of experience.
Yeah, I think seniors are going through their own thing right now.
Yeah, it's gone by fast, but it's also like, don't exactly know how to how to explain it that well, but like it's sad, but it's also like we've seen it coming for a long time. So at least for sophomore year was really fun. Junior year was also really fun, and it's like everything was over really quickly, but like you get kind of used to it, I guess.
Yeah, I think this will get better next year, right? I don't know. I just feel really sad because I don't even know how to phrase it, but I just really like the vibe of this class and like how everything was sort of going, like how everyone from not knowing each other or like barely knowing or like different friend groups to how we came together as a class. It was just such a great experience. And then to see how we're just gonna leave and exit right after the exam date. Because I'm pretty sure there are people who will not join this class. And then we cannot tell them to do anything because technically they can do that. Like it's not wrong for them to do that.
Well, there's sort of two groups of people in this class. There are people who are really serious about the subject and they're really trying to learn a lot about how this goes. And I think they have pretty good discussions. But then there's another pretty substantial group of people who just sits there all the time, never contributes anything. And I'm pretty sure they're just going through the motions. I mean, I can't get too much into what their homework looks like, but let's just say that they're just sort of going through the motions, counting down the days until it's over. So I don't really want to make those people keep coming for no reason. But
why would they join this class in the first place?
Well, you have to ask them.
I mean, probably like to fill up a spot. I mean,
I think it's complicated, Luke. I don't know. I think, I think some of them are legitimately having, reactions to this situation that we find ourselves in.
yeah.
And I don't really know what they're going through. I know that, some people have had their whole lives kind of turned upside down. And
Yeah.
that's tricky. And other people, I think maybe they still, I mean, most people said that they were interested in engineering, and maybe they don't think this class is that relevant to engineering, but it is. So
It is. Oh my god, it is.
or maybe they're just finding it
It
too
is
hard
weird.
right
Also
now.
weird for me.
Physics can be really, really damaging to the ego.
But that's like the fun of it. Like
Yeah.
you want to stand
Wait,
up.
whoa. I think that defies the definition of like why it would be why it would be fun if it hurts your ego. I don't
I don't
think
know. I don't know. Maybe I'm different, but like every time I do bad, I have a feeling of that I'm gonna do better. Like if I don't do better, I'm gonna be so mad at myself. So I don't know. It's kind of weird. That's what pushes me forward in this class. But I know it's different for everyone.
Yeah, I mean, I think that's a common trait amongst people who like physics. If you remember in class, I had that cartoon about how to solve a physics problem, where the person
Like
just
mistakes,
keeps,
mistakes.
yeah, mistake, 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 mistake,
And then
mistake,
he did it.
mistake. And then he does it, and then he looks and realizes the problem has like
A
5 more
lot of
sections. And then he's like, give up, become poet.
I know. But the people who got over everything and who got the questions at last, it must be
Yeah.
such a freaking experience to these people. But everyone can choose different path. It's not about like good or bad. It's just they're all different.
So I'm happy to meet with half the people if they want to the week after. Also, I think seniors only have 1 week. I also don't know how many other AP classes they're taking. So for seniors, it's 3 classes after the exam. So really only 2 being canceled-ish. I think it's a little bit longer for non-seniors, but there's not too many non-senior people in the course. So.
Yeah. Wait, honestly, Anita, I think you'll have a good time in the next 2 years, because I think, or at least for me, my experience at Williston was mostly like a lot of the classes were like this. Like you get to know the people and the kinds of people in the classes, and then you know like who's actually listening to the teacher and who's not really. But it's usually like that.
That's so good. I'm excited. It's so different from freshman year because I don't know, everyone's was like trying and then it kind of progresses. You get to pick like different difficulties and like different classes. You kind of like diverge and then you find what you like and then you go to college.
I think when you go to college, the biggest thing to look at is the other people who are going to. So like when you go around and you talk to colleges, the biggest thing to talk about are the other students who are going there and whether or not they're your kind of people.
Yeah.
Yeah.
Because the classes are really all pretty similar. I mean, some teachers are really great in college, but others are really not. And it's not like any college really has a monopoly on really, really good teaching. Although I think the small liberal arts colleges stress teaching more. But still, it's hard to predict that.
So not big Ivies.
Big Ivies are good for certain kinds of undergraduates. If you really, really know what you're doing and you need the resources of a big institution, that can be really, really helpful. If you're really going into investment banking, then a big Ivy is very helpful to get a job at Goldman Sachs. That being said, when we went down to New York City, I had lunch with a former student of mine who went to Williams, which is a liberal arts school, a very good one, but it's still a liberal arts school. And they were working on Wall Street. So I don't know that it really, really matters too much.
Yeah, that's what I heard from like a lot of people that I talked to about colleges when I was choosing. Like, it's mostly then, I mean, you're probably going to get the same kind of like good education or like about the same education most places. And you're really basically choosing the environment, I guess, or the place where you're actually.
That's why I say to pay attention to the peer group, like the other students there. Because different colleges definitely seem to appeal to different personality types, and I think you can find people that you really get along with if you think carefully about that.
So you guys are saying finding the right group is very correct, like is essential to do in college.
I think it just makes for a better college experience. I mean, the biggest part of college is the hanging out with other people, and the classes are good too. Don't get me wrong, but the people that you talk to are really some of the best parts of college. I think that's why people are so concerned right now about the situation, because the online classes are not really providing that.
Yeah.
Exactly. I don't know. Like in my history class, my teacher mentioned that a lot of people are not going to come back next year because of the virus and like how it affects many of the families in the states and their economic backgrounds. Like when I heard that, I cried. Like
I just teared up in class, and it was just. Is it true? Like, do you think
Coming back to Williston or coming back to
yeah,
college?
coming back to Wilson or like college or like any kind
Um,
of
I don't have good information about Williston. I know that I'm sure that there are people who are struggling. You know, if your parents lost their job because of this, that can be really challenging. I think Williston sometimes tries to help, but it's not like Williston. Williston has to. It's a business. It has to cover its costs. End of the day, and it is pretty expensive. And strangely, most schools like this actually spend more money per person than the tuition. I don't know where all the money goes. I tell you, it doesn't go to me.
Yeah.
But they usually spend more. So sometimes for unit conversions, I'll have the class figure out how much money I would make if they all just paid me directly.
No, that'd be too crazy.
that might be
That wouldn't make it. That,
So if I just, set up online classes, you can all just, Venmo me for class. I would make a lot more money.
Make it pay per class you attend, actually.
Yeah.
That would be. Then teaching would be such a competitive career.
Yeah, it might be heading that way. I don't know. Nobody really knows.
Is that a bad thing though? Specifically, to making it a competitive career?
It depends on your point of view. The study of economics is really the study of who wins and who loses. So some people are going to win and some people are going to lose.
Yeah.
It's not necessarily good or bad. I think that there are definitely people who are really, really strong lecturers. And maybe there's something to be said for an idea where everybody just goes and watches them online.
Oh, yeah.
Okay, and that's kind of like the market for actors. Okay, there's only a very few number of actors who are going to have that charisma to succeed in acting, and the rest of the actors are making nothing. So that would make teaching sort of a winner take all business, like acting. And acting, the top 10 acting people in Hollywood probably make 90% of the money. I don't know, but I'm just making up numbers, but I'm sure it's a lot. But I do think that the other thing is that there's something called cost disease. So as we manage to make more and more things with less labor in factories, the productivity per worker in a factory has gone up really a huge amount over the past 100 years. But the productivity of a teacher is really the same. Okay? Yeah. So in order for these things to balance out, the teacher has to be, that's one of the reasons that education is costing more and more and more, because you're sort of balancing it against a TV. Which the TV is getting cheaper and cheaper and cheaper because it's being made, not the amount of people input into a TV is getting smaller and smaller and smaller, but the amount of person hours into teaching is really the same. And there hasn't been huge efficiency gains. So some people think that we can just turn everything online, have 1,000-person classes, and then the best lecturer will lecture to those 1,000 people. And that will be a huge increase, and then we'll see a massive drop in the cost of education. Personally, I don't think it's going to work for a lot of people. I can tell you that some people do fine in online education, but some people really have a hard time motivating themselves.
Yeah, no,
This would
but
be
like that definitely makes sense. Like I no, because I lose all motivation to do any work whatsoever if I'm at like home, rather than like when I was at school, I was being more productive, I guess.
Yeah. So that's why I don't think it's really going to happen. I think that
Yeah.
these people are thinking about human beings as if they were ideal workers who didn't need motivation. But I think a big part of what school does, putting people in classrooms, is it gives them a lot of social pressure and
Yeah.
like motivation to do their
Competition.
work, competition, and like and
Yeah,
just
but like not here.
human beings are herd
And I
animals.
think that, yeah.
Exactly. I need to show you guys a photo of. Is it this photo? It's me and it's how my friend took a photo of us in math class, and you can literally see like how everyone is on their phone. Let me just find the. Yeah.
Is this online math class or real
No,
math?
it's the Wilson. It's Mr. Whipple's AP calculus class.
Yeah.
Yeah, and then it was so funny because there was four of us like doing waving, and all the other heads are like down. Can you guys see it?
Yeah, it's taking a little bit to download for some reason.
Yeah.
It's not a very big file, but
Yeah, it's a screenshot.
like so everybody's going like this. But you can see that most people are
No,
looking.
this is a greeting, like how we greet. Okay, so then this math class is kind of like tradition to greet each other, but
Yeah.
like since online class, like everyone's just looking down.
Yeah.
Yeah.
Yeah. The majority of people do appear to be looking at their phones, or the classic forehead
Yeah.
view, top of the head view.
Yeah.
I mean, me too sometimes, but like not really. But we kind of lose the motivation.
Yeah. It's been a thing in real class too, but I think it's easier for the teacher to just sort of walk around and, go.
Like reminding us to do
Yeah.
work.
I think it's also just easier for the students because like they have a separate environment of one thing and another thing. Like home is comfort and stuff, but like school is where work gets done.
Yeah. No, it's true. And when I was in school, I found that I got a lot more work done if I went to the library. And I just
Oh
put
yeah.
myself down at a desk, got out my homework, and then I could focus and do it.
Yeah.
But it's hard. It's much harder to do that at home. You should try to do tricks to yourself. Set up a workspace. This is work. It really, I mean, nobody does it anymore, and I understand why, but it helps to dress up instead of a t-shirt. Just, getting yourself in that mental position of this is what I'm going to do. But if it's a skill you can master, I think it really is one of the most essential skills to success in any field is just getting it done. Just buckling down and actually doing the work. And you'd be surprised at how few people actually do this and how inefficient most people are. And if you can just sit down and actually do the work, you can get really far, regardless of your IQ. I mean, as long as you're basically competent.
Is that how people are separated by their motivation?
Mm-hmm. For sure.
I like the answer.
Dr. Schmidt.
Yeah.
In college, from like my first course, what do you think I should take for physics or like physics related?
Well, they'll have a calculus-based physics that they'll expect you to take. I would think.
Like the physics C.
Yeah.
Okay.
Electricity and magnetism and kinematics.
But they're not going. I mean, this class is not going to get you out of physics for majors. So if you're planning on majoring in engineering or physics or something like that, then this class is not going to be a substitute for that.
What about
Oh,
physics?
yeah, no. I was just like thinking of dual major or like a minor in physics or something like that.
What is your current major?
Computer science.
That's so cool. Okay. And Visa.
Hi, I'm sorry I'm late. My parents don't seem to understand that I'm still at school, and they take me out really often. So sorry. I just got back. Sorry.
Yeah,
No,
those
don't worry.
parents, they're always trying to
Right.
make you do badly in school.
They say that it's okay to miss classes because those are like not actual classes for the grade, which is, I mean, kind of true, but also not so much.
Yeah.
My parents say don't miss classes because we paid for them.
Oh,
Yeah.
I would prefer my parents saying that, honestly. Okay. Sorry. So where are you? Where were you before I came?
So Anita and Luke both came to the morning class yesterday.
Right.
So we were just discussing college.
Oh, well, that's fun. So
So what would you like to discuss?
I think I got like the first question pretty well. But I wanted to talk about like the second half of it. So with the moving coil, because I yeah,
Like this one?
like yeah, this one. Mhm. All right. So here my question, I guess, or not the question. So okay, we know that the current is induced when there is change in magnetic flux. We know that there will be change in magnetic flux because the magnetic field generated by the magnet is not uniform. As we move along the magnet, the magnetic field will change, like the perpendicular component of it going through the coil will change. Therefore, the magnetic flux will change. Therefore, current will be induced. So when I'm thinking about the magnitude at different points as the coil is moving forward, I don't know whether I should think about it in terms of like the angle at which the magnetic line like enters the coil, because like um we know that at the first position, um like it would be almost well, it will be a bit tilted, but like it will be pretty much horizontal, right? Like, well, I mean, okay, it's gonna be, yeah, mostly tilted.
Only the part that is perpendicular. So each vector. So let's say that I had a magnetic field vector right there. Okay.
Right.
And it was pointing like up and to the right. Now that can be decomposed, right? You can make it into that vector plus that vector.
Right.
Okay, but only the vector that is perpendicular to the plane of the circle
Or what we're considering.
is going to contribute to the flux. This other vector that is this other component that is parallel to the plane of the circle has zero contribution to the flux.
Yeah. Yeah.
Okay,
So yeah, go ahead.
so you don't have to consider it. You just have to consider it. So you can consider all of the magnetic field lines going through this as if they were just all pointing this way. Because that's the only thing. Those are the only parts that matter.
Okay, but we know that it will be that the magnitude of the horizontal component here will be like second largest, right? Or, I mean, out of the three. So, okay, we know that the position that is in the middle of the magnet, there our magnetic lines are basically all parallel to the magnet. So there will be no change in magnetic field going through, no change in magnetic flux, therefore no current induced in this scenario. Okay, but when we go off the magnet, there is this sharp turn that basically all the magnetic lines take because they need to go to the south pole. So I don't know how to think about that moment of like coming off the magnet, because the ones that are just like on the sides of the magnet will be almost fully vertical. Therefore, there's like no horizontal component to it. You know what I mean? Like if there was a magnetic line that followed exactly along the magnet and it just took a sharp turn right before that, so there was basically no horizontal component to it.
Well, so what you should do is think about, on the sum of all these effects. Like there's going to be a lot more lines coming in here than any potentially fringy lines over here that are going this way. So
what about these lines? Can you see me annotating?
I can see you're making green.
So
but,
I mean,
but there's
yeah.
a lot fewer of those. There just really aren't too many of them.
Okay, so
Right.
we are basically ignoring them.
Well, yeah, they the same way that we would ignore, Bill Gates giving you $1. It would have no effect.
Wow.
It would have no effect on his wealth, right?
I mean, I think it'd make you happy though.
Yeah, that would definitely make you happy. And I mean, even the situation itself would mean that you are close enough to him so that he knows who you are and actually willingly gives you $1. That's a pretty big
Yeah,
thing.
especially these days. He must really trust you.
I know. All right. So basically, as I will be, well, I mean, I'm going to fix my paragraph length response, but like I have the first paragraph talking about like general principles of why current is induced, what will affect the magnitude, and what will define the direction. And then I have like 3 lines that says like position 1, direction that, like magnitude that, and then position 2 that. Would that work?
Yeah, what did you end up with for your directions?
So it goes counter. Well, okay, if you look, oh, yeah, that depends on how you look at it. So okay, let's.
It tells you with respect to the end view shown. So like
Yeah.
you are looking this way.
Right. Okay. Well, yeah, I answered it this way, so that still makes sense. So it will be going counterclockwise at position 1. It will not be going anywhere at position 2, and it will be going counterclockwise again at position 3.
So at position 1, you have if I draw the magnetic field going through the circle at position 1, they're all the magnetic field lines are going to be going
Right. So we
into
want
the
our magnetic field generated by the current going outwards. Therefore, it goes counterclockwise.
Okay. Because as I move it this way to the right, these magnetic field vectors are getting bigger and bigger and bigger. So
Right. That's a change in flux. Therefore,
yes.
at position 3, it should be going clockwise because
Yeah.
Right. We're moving away from the end, therefore magnetic lines are packed less dense. Right.
Yeah.
Yep.
So they're going the same direction, but they're packed less dense, and so the current opposes that.
Right.
Okay.
Okay. You can do that. Okay. So I guess for the rest of the worksheet, I'm pretty set.
Okay. I thought C was pretty tricky.
See?
C.
Like
it-
2C?
yeah.
Well, okay, I answered that it would be attractive because the current induced in the in the coil will be will generate a magnetic field coming so in that direction, like to the right, if we're looking side view, and like at us, if we're looking end view, and at the side, well, and the magnet's north pole will be generating a current that goes in the south pole. So when so essentially the coil simulates the north pole of a magnet. So I thought that they would be attracted to each other, like the same way a north pole and a south pole of a magnet would.
So
Does that make sense?
if I consider two magnets here that I'm drawing, right? These two magnets, are they going to repel each other or be attracted to each other?
Wait, so it's not right. So if it's coming in there. Yeah, well, what you drew just now will be repulsive, okay, of course. But I'm just thinking.
And you see how the fields are in opposite directions?
Right,
And that's
yeah.
making them repulsive. And then if you have a clockwise view here, right, this is then going to go, the magnetic field is going to be coming out.
So it's going to be opposite, and therefore they will repel.
Yeah.
Okay, yeah, this makes sense.
Yeah, I told you it was tricky.
I was confident that I got it right. Damn it. Yeah. For some reason, I thought about it as a north pole, not a south pole of a magnet. Yeah, well, okay, that makes sense. Yeah, well, anyhow. I mean, for the rest of it,
There wasn't anything
I'm
else.
comfortable seeing that I'm confident with my answers right now, because maybe I have some problems that I don't know exist. But okay, just one question about the wording in a question. So it's B1 in question 1. There is like clearly label path P1. So where are we supposed to label it? Is that like in B2?
Oh, true. I had that question too. I had that question too.
So down here,
I labeled it in both places. Is that okay? In both diagrams?
I think that I should have said, clearly label the path P1 should be the second sentence in B2.
Right.
Yeah.
And I don't know how that got changed. So you should take the, so 1 should read, calculate the magnitude of the force on the proton as it enters the field, period. And then 2 should say, on the figure below, sketch a possible path of the protons that travels through the magnetic field. Clearly label the path P1. And then 3 says the second proton, clearly label the path P2. So both P1 and P2 should be on the same diagram so that you can compare them.
Yeah. Okay.
Does the AP test approve of using different colored pens, like in answers?
I don't know that it's ever really come up before.
So like,
yeah, I don't see why not.
nice. I think that just makes
But
it more easier.
I think it just makes it more clear. I mean, how you label it, it just says clearly label the path P1. So if you want to label it as red and then make P2, you know, fuchsia or something, then that, or orange, you know, then that would be a clear difference.
Do you think they will accept OneNote printouts? I mean, they said that they accept like PDFs and documents.
OneNote printout, as long as you make sure they fit nicely into one page width. My PDFs printed from OneNote can sometimes be extremely difficult to read because they'll break the page in very strange places.
We just have to make sure it fits in like the one page thing,
yes.
right? Okay.
As long as it's no more than one page wide. A bunch of pages long is okay, but more than one page wide really confuses OneNote when it comes to print. And it will be very difficult to read.
Okay.
One thing we did in
I'm
class.
probably gonna go with pen and paper anyway, but.
Yeah, I think that's what I would do, but I like pen and paper. One thing we did in class was we looked at, I put in the class AP exam day information website. And then I looked at it.
Yeah.
Trying to find it in my, so then it looked like this. And here's that web page. And so it says, be prepared for exam day. You can click here, and that takes you to this. These are some things that you should do. You should review the exam demo, make sure that it works on your computer. Launch an interactive exam demo, practice submitting, those sorts of things. In OneNote, I also put the checklist.
Mm-hmm.
So I would go through and check all these things, making sure that I'd done all these things. They also have confirm your email address. So make sure you're getting email from College Board and the email that you want to be using. You have until tomorrow at 5:30 p.m. to change that. So that's really something I would check.
Change. What do you mean? In what way change?
Well, if it's not correct. So.
All right.
And then exam day, just make sure that you have your exam ticket email, your AP ID, your device is fully charged. They recommend using Chrome, but I would try it out ahead of time, making sure it's working right. You're allowed to use your class notes. You're allowed to use textbooks. You're allowed to use previous assignments and assessments. And for AP, they just, they have the information, the equation sheet.
Mm-hmm.
So make sure that that is available to you.
Okay.
Wait, We can still look at our physics notes, right?
Yeah, it says up here that permitted your class notes.
Yeah.
I really wonder what kind of a question they will put up there so that we will be having trouble solving it even with our
Yeah,
class.
exactly. Like, I have no clue. But I feel like it might be different from the traditional ones. So,
I think it'll be slightly different, but I think they'll make you write a paragraph. And I think they'll make you design an experiment. That's my guess.
yeah. I don't know. It's just like with all the notes, I feel like everyone's gonna get a good score. So the curve will be.
I
They
honestly
don't.
don't think so, though. Like, some people are having trouble with technology, and just getting submitting everything on time will definitely be a problem for quite a lot of people.
Yeah, I think that I don't know how to predict the percentage of people who will get certain scores, but they're not going to curve it like 20% of people get a 5. What they're supposed to do is curve it against a college class that has already been graded. So that's how they calibrate the test. So if, let's just say that everybody who would normally get a 1 just decides not to take the exam.
Oh.
Then this year there will be like 1% of people getting 1s. Okay. They're not going to force a bunch of 1s just because everybody who would get a 1 decided not to take it. But there's something called that graph that I showed you, the Dunning-Kruger effect. People who would get 1s often think that they're really good. And this reality never seems to sink in for them.
That's okay. I mean, that doesn't make other people less proficient.
No.
Just those. Yeah.
It might be a psychological defense mechanism too, as we were talking about before you showed up in FISA, that physics can be very damaging to the ego.
It's fun.
To the ego. I mean, just as any hard science, that's not something specific to physics, though.
No, but I feel like people just have a stereotype towards physics, like specifically physics. I don't even know why, but
yeah. Well, I think it's because we were coming out of a time in history when physics was very ascendant. The Cold War and the space race and
nuclear power
and nuclear weapons.
Yeah.
Before that, before World War II, physics was not really part of the popular culture. It was just something practiced by obscure, it would be like majoring in anthropology.
Yeah.
Okay, there are people who do it. It's just really obscure. And then after World War II, that changed big time.
Even after industrialization.
Yeah.
Engineering was becoming more.
Well, yeah, that's engineering.
Yeah.
I always thought it was more like physics is like the top of the chain of the sciences. So like everything is physics, and then after that everything is chemistry, and then the bottom is biology. Just because you can have everything without.
That's not exactly true. I mean, physicists often say that. They say that, well, everything in chemistry can be reduced to physics. But that's not actually true. One of my PhD advisors, Roald Hoffman, was very fond of saying, a big counterexample to that is the idea of the chemical bond. It can't actually be described by physicists. It's this abstract idea that we have to help us make sense of chemistry. It's really a metaphor for what's going on. And it's a high-level metaphor. And what is actually going on with the electrons is not solvable for physicists. And so therefore chemistry needs to step in and provide this metaphor that's really, really helpful to understanding how atoms act. I'm sure,
how do you define like whether this definition comes from chemistry or from physics?
I think partially these sciences have developed their own cultures. So like, how would I know that something was Russian? Well, because the Russian people use it and it's part of what they talk about.
All right.
So the idea of a chemical bond is not something that physicists have really, they don't have a great handle on it. That what they do is that they can describe hydrogen. So they can describe a hydrogen molecule with just one electron. They can do that really well. But put in the second electron and or make something more complicated than hydrogen, and they can't do it. This is not something they'll admit very readily, but it's true. And so if you're going to describe a protein that has very, very complicated bonding, then you're going to need ideas of chemical bonding, which are metaphors that physics can't really explain.
Deep.
And biology has similar things too that chemistry can't really explain too well.
So the three
Cool.
sciences work together to create a general conception of what we see in the world. Like,
Well, we're trying to understand the world, but you should also remember that we don't have a very good understanding of the world. There are things called dark matter and dark energy, which account for 95% of the universe.
yet we don't
And
know.
we have no idea what they are and how they
That
work.
makes it really fun, but frustrating.
I don't think fun is the word to describe this.
It makes people want to explore it.
Yeah. It's intriguing, it's mysterious, but I mean,
Well, so one of my favorite quotes around this idea in FISA is President Kennedy gave a famous speech at Rice University in Houston in 61 or so. And give or take a year. And in it, he laid out the case for putting a person on the moon. You know, he said before this decade is out, we will send a person to the moon and return them safely to the Earth. Right? That line is well known. Like that line gets repeated a lot. But another one of the parts of the speech that I really like is he said that we're going to do this, okay? And we do these things not because they are easy, but because they are hard. That's what makes us human beings.
yeah, I also heard about it. Yeah, that's a really nice quote. And it's pretty accurate. Like if a person is inquisitive, they are always bound like to challenge their knowledge and just go beyond and beyond.
Keyboarding tip sheet for 2020 AP Calculus exams.
Yay!
Oh crap! Wait, actually, I might want to download that
Me too. I think I might want to do that too.
because
How do you, Anfisa?
but like I'm not.
I want to look at this.
Am I really gonna use like typing? Wait, what the? Wait, these are just regular. It's not a tip. It's just how you use this keyboard. Wait.
Well, this is
This
just
doesn't help.
regular, like.
I don't think using this is a good idea. You can just handwrite it.
Yeah,
would
no, that's so
like-
that's so
That was
bad.
This is not going to make it easier for you. It's going to take you way too long.
That's horrible. Yeah.
What are you talking about? Yeah,
think
sorry, I was
that-
kicked out.
So there's a sheet here. I saw a keyboarding tip sheet for 2020 AP Calculus exams. Don't do this. My tip is don't do a keyboard.
Yeah.
Oh no way. I mean, yeah, I read this. This is ridiculous. No one has to deal with it. This
No, don't do
is
this.
so bad.
It's so much harder.
Yeah.
I know.
I mean, it takes a really long time to write.
I mean,
this stuff.
unless you're some kind of a latex expert, maybe then you will
Oh,
be.
even then, it's not. It takes so much longer to type it. I don't know. I always found
Yeah.
they only did it when you had to publish something.
It was only when like are mainly like using words. I feel like when you're explaining something in words, you use the keyboard, but for
Yeah.
math stuff, it's pretty bad.
Yeah. All right. I have to go. I have class at 8:30 tomorrow, so I don't.
Right.
I'm not gonna stay here too late tonight. But
Tomorrow starts with a G.
yes, I have honors physics first
Fun.
thing tomorrow.
Honors
I missed
physics.
honors physics. It was a good class.
Yeah. Would you recommend that somebody take AP Physics 1 as in their sophomore year, Anita?
I would, or 2. 1 is like honors physics, but 2 is different.
Yeah.
Both are really fun. Are you planning to teach AP Physics C, or will you get a petition? Or not really?
Honestly, don't know. There's been a lot of discussion about that.
Oh, really? Why?
I think this year more than others. Usually they wait until the summer anyways before I learn what I'm going to teach. So.
Oh, so you don't get to pick what you're gonna teach?
No.
That's
I mean, it's a
okay.
discussion. There's a little bit of give and take.
Are you talking about the AP Physics C, the electro specified one, or the other C?
I think both.
Williston puts them up both into 1 year.
Oh.
It's tough. Some schools split it up. My previous school did it over 2 years, 1 year of mechanics and 1 year of E&M, which was a lot easier for people.
Yeah.
I feel like, I still feel like, I don't know. I think Physics 2 was a good step though, from honors physics to Physics 2 to AP Physics C.
Yeah.
Like, I feel like AP Physics 1 or AP Physics 1 wasn't really doing much, I guess.
Especially if you learn honors physics.
Because I think we were fine, even though like we weren't really acquainted with honors physics that much because we forgot it mostly. But like, I think
your force
overall we were
diagrams are
fine.
pretty bad at the beginning of the year, but they got better.
Yeah.
You really expose people like this, Dr.
Dr. Schmidt, so for AP Physics C, do you have to take Calculus BC, or like is this?
I think you
They
have to
say
have,
that you have to be co-enrolled in a calculus class, which is really weird because I mean, can I take? Well, if I'm taking AP Calculus AB this year, and I'm planning like to do stats and honors discrete next year, like would it work for me to take Physics C?
what math are you in this year?
Calc AB.
I think so.
Right.
Or
So we could have taken AP Physics C.
it says or coherent, like, yeah, well, I don't know. I'm gonna check that. I thought you had to have completed a calculus course.
That's what I thought too.
Yeah, actually, yeah. So I tried to enroll in AP Physics C this year, but so yeah, Mr. Kainlong told me that it's really heavy on calculus right from the beginning of the year. So even though the course book says that you are allowed, they don't recommend it. And I don't know why they wouldn't change it in the book.
I don't know. I didn't. I just checked the book. You're right. I always thought it was completed calculus.
So yeah, I talked to my advisor, and she said that sometimes they would allow you to enroll only if you are co-enrolled. Like they won't consider it if you completed the course before. because that happened at her previous school. I don't know why, but that might be the case. So I would really appreciate it if you could maybe tell me.
Well, at least I'm pretty sure that it's because AP Physics C contains BC calculus courses or BC calculus topics, and not
So-
necessarily AB calculus topics. I
Oh,
mean,
so they
it's
have
a lot of the like BC and multivariable, because at least in BC calculus this year, they were using the right hand rule, and it was a lot of vector stuff, while in AB calculus last year we didn't do almost anything with vector stuff. I mean, we still learned integrals and the derivatives and relative rates and such, but it was not like the BC calculus or the multivariable stuff that we learned this year.
Right. I don't
So
know what
I've
math courses to
never,
take.
yeah,
I don't think
I would ask, I would send Mr. Kane Long an email. He might know better whether you should, so you don't want to take BC? Is that what you're saying?
Yeah, well, I just thought that I would study the topics on my own and then just do the exam, because I really want to take stats and honors discrete. Well, I mean, if I could, I would take honors discrete, BC, and stats, but like 3 courses per year
think
that, well,
Stats
math
is
courses.
easy to self-study. It's easier than BC.
Yes, I definitely think stats is an easier course than BC.
Yeah. So I feel
Um,
like if you want to study, go study stats on your own.
Or at least even, or wait, if you're already taking 6 classes, then definitely study stats on your own. But like, stats isn't, I mean, I don't mean to be mean to like stats, but it's not that hard. I mean, I didn't find it as hard as like
I know that it's not
concept-wise.
hard, but like I wanted to build like a solid foundation, but if it's actually that easy, then I can definitely self-study it.
It's like Chinese people evaluated the time it takes to study BC. It was like 24 hours, and then for stats, it's only 6. If you pay
Wait,
fully
what?
attention and studying, I mean, Chinese are crazy, but like, see the comparison. Like, my friend literally learned stats in 6 hours following that program, got a 5 at the end of year in her freshman year. So I think it's more doable than BC.
Oh, then okay, I didn't know that. Well,
And then it
that
was
is-
in pre-calc at that time.
But you also have to remember BC contains almost like basically all of the AB calculus topics also. So like if you've already learned AB calculus, then you've known most of BC. You don't
Yeah.
know the multivariable stuff that much though.
all right.
When do they do like surface integrals?
Surface integrals?
Yeah.
AB.
Oh, we might have done that. I think that's still AB. Surface integrals.
We learned that, yeah.
Because I think that's all you really need for electrostat. Like
Yeah, that's what I
electricity.
thought. Like, you just need to calculate the area underneath the curve.
Yeah.
But like,
so like what you might need calculus for. So if we think about this magnetic flux thing, if you have an area,
like the cross-sectional area was something
Yeah.
you definitely needed, because you can calculate the equation of a perpendicular line if you have a perpendicular line if you have 2 lines that are perpendicular, or I mean, if you have 2 lines that cross each other, you can calculate the equation of a perpendicular line that is perpendicular to both of those 2 lines. This is 3D space.
Oh, okay.
So
All right.
then you could calculate like the cross-sectional area, I guess, of that is perpendicular to,
Okay.
or at least this is, I'm assuming, I haven't taken it, so I don't know, but like you could calculate the cross-sectional area of the magnetic field, I get, that actually is perpendicular and is actually acting on the loop,
Right.
like a wire
Right.
that's moving,
So
I guess.
that's what
I
that's
get
what
you're
you would do in in mechanics, but I don't think physicists in general don't usually require complicated calculus. In fact, every physics course that I actually took always had like a quick 1 day of calculus, everything you need to know, and then that was really all you needed to know.
All right.
So
Okay, go ahead.
I don't know if you could shoot Mr. Kane along. I've never actually taught if he's a physics C before, so I don't really know for sure. I certainly don't know how it lines up with calculus A, B, or BC.
All right. Well, I didn't know that stats was as easy. So if it is, then I think my question is settled. I'm just gonna do BC and discrete and self-study for stats. So like the concurrent enrollment is out of question.
Well, that's really what you should do in FISA if you want to also like look like the stronger student. Like when somebody reads a transcript and it says BC in honors discrete, they'll be like, oh, that person's really, strong in math. If it says stats and discrete, they're going to have to look closer. They won't necessarily think like for good or for ill, stats is just considered the less rigorous course. Just like AP Physics 2 is considered less rigorous than Physics C. It just is.
Right. I mean, I didn't know that, so.
What classes are you going to take next year?
So I'm gonna do. Oh! I actually gotta go.
Okay.
Sorry. We went over time. Yeah, I think we can chat later.
All right.
Yeah. Thank you. Bye.
Bye. All right. I would like to go too because I would like to go to sleep.
Yeah.
So thank you. See you later.
Dr. Schmidt, thank you.
Sleep well.
Sleep well.